Hi everyone, today we're talking about how our world is changing. We are looking at three massive technologies coming together: driverless cars, the Internet of Things, and machine learning. Let's look at what the future holds. Overview of emerging technologies. Instead of looking at these as separate tools, we need to see how they connect. When self driving cars, connected devices, and smart brains overlap, they create what we call physical AI, machines that can actually think and move in the real world. So, the pie chart graphic, think of it as a three-part team. The Internet of Things is the body that feels the world, machine learning is the brain that understands it, and driverless cars are the real world application, using both to move us around safely. The trifecta of 2026. When these three work together, everything happens in a split second. Devices collect data, the AI processes it instantly right inside the car, and the vehicle makes safe decisions on the road without any lag. So now we're going to talk about module 1, driverless cars. Let's start with module 1 and focus on driverless cars and see how self-driving technology is changing transportation. So there are different levels of self-drive. Level 4 cars can drive themselves but only in specific mapped areas. Level 5 is the ultimate goal, a car that can drive anywhere, anytime, in any weather, completely on its own. The evolution of autonomy, this timeline varies from 1925 to 2026. This isn't brand new. We went from early remote controlled cars in the 1925 to military tests in the 2000s. Google launching its projects in 2009. Now we are seeing self-driving taxis and trucks being used all over the world. So, operational architecture. How does a car actually drive? It follows four simple steps. It looks at what's around it, finds exactly where it is on a map, predicts what other drivers or walkers will do, and then plans the safest path forward. Graphic sensory stack. So, to do this, the car needs sensors. It uses a mix of LiDAR and radar, which shoot out lasers and radio waves to map the world in 3D, alongside high tech cameras that can read the road signs and see traffic colors as well. So, the key players in 2026: Waymo, Tesla, Aurora, Beidou, Apollo. Big companies are leading the race. Waymo runs thousands of regular robot taxis. Tesla is building self driving systems for everyday drivers. Aurora is automating big shipping. Aurora is automating big shipping trucks, and Beidou is growing massively across Asia. Right. Societal solutions. So, the what they provide is a 94% safety chance, a 100% accessibility, and a 60% efficiency. Why do we want this? Because it can fix massive problems. It can cut human error accidents by it can cut human error accidents by 94%, give total freedom to the elderly and the blind, and make city traffic move 60% faster. Okay, so next slide. Ethical and technical obstacles. But there are still roadblocks. We have to solve tough ethical questions about accidents, protect cars from hackers, update old driving laws, and make sure cars can handle extreme weather or random road debris. Now we're going to move on to the next module, the Internet of Things. Uh, this is the massive network that connects everything together. So, ubiquitous connectivity. Simply put, IoT is a giant network of everyday objects embedded with sensors that talk to the cloud. We are on track to have over 75 billion connected devices globally, making smart choices without us needing to click anything. The path to connectivity. This timeline varies from 1982 to 2026. This started way back in 1982 with a smart vending machine. Then we got smart homes with Alexa and smart lights. Today, it's much bigger. It's about smart factories, power grids, and massive business networks. System architecture. The system works in four easy steps. Sensors collect info, fast networks like 5G or Wi Fi send it out, cloud software reads and processes that data, and the final helpful info is sent straight to your phone application. Communication categories. IoT covers four main areas: consumer tech like smartwatches, industrial tech like factory robots, commercial tech like smart buildings, and medical tech like monitors that send data straight to doctors. The digital backbone. Managing billions of devices takes a lot of power. Tech giants like Amazon AWS, Microsoft Azure, and Siemens provide the huge cloud systems that serve as the backbone for all of this data. Real world impacts: operational efficiency, digital twins, smart cities. The real world benefits are huge. It helps us save energy, build smart cities that track trash and utilities, and create digital twins, which are virtual copies of real machines used to test things safely on a computer first. The cost of connection: data privacy, botnet attacks, interoperability, e waste. Of course, there are downsides: constant connection risks or privacy, smart gadgets can get hacked, different brands struggle to talk to each other, and thrown away tech creates a lot of electronic waste. Module 3: Machine Learning. So, machine learning: if IoT is the nervous system, machine learning is the brain that makes sense of everything. The cognitive backbone. All programming required writing rules for everything. Machine learning is different. We just give the computer lots of data and it learns the patterns and figures out what to do all on its own. The intelligent timeline. This timeline varies from 1950 to 2026. This journey started with Alan Turing in 1950, moved to chess playing computers in the 90s, and exploded with ChatGPT and AI art recently. Today, we are entering the age of AI agents that can do multi step tasks for us from start to finish. From data to intelligence, training phase versus inference phase. This works in two steps. First is the training phase, where the AI studies huge amounts of data to learn. Second is the inference phase, where we give the trained AI a new problem and it instantly makes a smart decision. Learning paradigms, digs. Supervised, unsupervised, reinforcement, deep learning. We teach AI in a few ways: supervised learning, where we give it the right answers to practice; unsupervised, where it looks for hidden patterns; and reinforcement, where it learns through trial, error, and rewards. Advanced applications. AI can now understand text, sound, and video all at once. It's helping scientists discover new medicines, translate languages instantly, and track global shipping. We are also building explainable AI so humans can understand exactly how the AI made its choice. Leading entities: OpenAI, Google Vertex AI, Anthropic, and Databricks. The biggest name in AI right now are OpenAI, Google, Anthropic, who focuses heavily on building safe and ethical AI, and Databricks, which helps companies organize their data. So, the module 4: the connected future. Let's look at how all three of these technologies join forces to build our future. If you look closely, a driverless car is just a giant connected device on wheels. It uses IoT to feel the road, uses machine learning to think, and acts instantly to get you where you need to go safely. So, transforming the modern life. This mix is going to change businesses, delivery, and how we live our daily lives. The future is connected, automated, and intelligent. So now I'm going to show you the flowchart that I've made from Miro as well. So this is a large flowchart mapping out the complete machine learning lifecycle. To see how AI is actually built, this chart shows the full machine learning lifecycle. It starts with a real world problem, then moves to gathering, cleaning, and splitting data. The key part is the checkpoint. If the AI's guesses aren't accurate, it loops back to tune the settings and train again. Once it passes the test, it gets deployed and monitored. The next flowchart: simplified flowchart showing a streamlined machine learning pipeline. This chart shows a simpler, faster version of that same pipeline. It moves straight from collecting and cleaning data to picking an algorithm and training the model. Just like before, if the performance is poor, a quick feedback loop gets us adjust the parameters and try again. As soon as it works well, it goes straight to launch. Now, last flowchart. So this flowchart is showing the vehicle navigation loop and safety checkpoints. Finally, let's look at how a self-driving car actually drives on the road in real time. Sensors constantly collect data, the car processes it, plans the route, and controls the steering and speed. It features a critically safety checkpoint. If anything unsafe is detected, it hits an emergency brake instantly and loops right back to the sensors to find a safe way out. If everything is safe, it keeps driving until it reaches a destination and parks. That's all from my side, and thank you for listening.